Next is how the ammonia, nitrogen and H3N is removed, and that is through the removal processes. Here, we have the cross-sectional diagram of the MSL. We can see that the water is flowing in and the organic matter found in the influent is stuck to the surface of the SMB or the PL. The microorganisms that grow on the surface starts degrading the organic waste, thus killing it and removing it from the surface. The SMB and PL also absorbs a large amount of ammonia, nitrogen and H3 that enters the system. This accumulation will then be converted to nitrite and nitrate due to aerobic environment. We can also control the activity of the microorganisms in MSL by using the ventilation system. This is because the whole process occurs in an aerobic system, and besides removing ammonia, nitrogen, the MSL is also capable of lowering the COD, BOD, suspended solid, and also removing soluble reactive phosphorus. However, excessively increasing the ventilation will reduce denitrification and decrease the removal efficiency. We then have the comparison between MSL and the other methods. The first point being MSL is affordable and causes less hassle. This is probably the biggest advantage MSL has over its competitors due to how low the investment and operational cost needed to run it. MSL also produces little to no sludge and causes infrequent clogging, which means less maintenance needed. It also requires minimal electrical energy to run, which means we can save more on the electric cost. MSL also does not need a big land. We can treat 100 meter cube of water per day using MSL with only 100 meter square of area. However, the other methods can take double the area and treat 90% of what MSL has to offer. MSL is also an underground system, which means ease maintenance and uses minimal labor. MSL is also friendly to the surrounding because it does not produce any noise pollution and also does not become a habitat for pests. It does not also produce any unpleasant odor such as fishy or sewage odor. Last but not least, we have the MSL costs. Here we have two assumptions made. The first one is the area of MSL is 100 meter square to treat a total of 100 meter cube of water per day, and half of the total volume is made out of zeolite, which is 50 meter cube. So for the permeable layer, we have 1 ton of zeolite being 627 ringgit, whereas for 60 ton of zeolite, it is 37,629 ringgit. To reduce the cost, we can substitute the zeolite with expanded clay aggregates, oyster shells, or even use granular activated carbon. Following that, we have the SMBs, which is the soil mixture blocks. So 1 ton of SMB is 480 ringgit, whereas for 120 ton of SMB, it is 57,684 ringgit. 70% of its composition consists of silica sand, whereas the other 30% consists of charcoal, sawdust, and iron. This brings us to a total cost of MSL, which is 101,613 ringgit, including the glass tank.